Everyone, we are going to do lesson 21, which is a really important lesson in Algebra 1. So I didn't want you to do this on your own, so that's why I made this video. So let's get started. Let's just talk about exponents for a minute. If we had 3 to the 5th power, that's the same thing as writing 3 times 3 times 3 times 3 times 3 5 times. The bottom number is called the base, and the little number up on the top is called the exponent. The exponent tells us how many times we need to multiply the base by itself. Now, if we have variables, so say we have x to the 5th, that's the same thing as saying x times x times x times x times x. If we had x to the 2nd times x to the 4th, that would be the same thing as x times x times x times x times x times x. This is x squared right here. That's our x squared. That's x times itself 2 times, and this is x to the 4th. If we added those all up, how many x's we had, we would get 2 x's, and 4 x's would be x to the 6th power. So when we're multiplying, let's do one more. If I had p to the 5th times p to the 12th, one way we could do this problem is write out all the p's. So we could write p times p 5 times. That would be p to the 5th. And then we could do p times p times p times p, and we would go on for 12 times. And that would be p to the 12th. That would be p to the 17th power. Now, can you see the little pattern here? What if we had p to the 199th power and p to the 3000th power? We wouldn't want to write them all out, so there's a rule to help us know what to do with exponents. And this is the rule. It's called the product rule for exponents. And it says, if m and n are real numbers and x is not equal to 0, then x to the m power times x to the n power equals n to the m plus n power. So if the bases are the same, so these are the bases are the same, and you're multiplying, then you add exponents. You add exponents. That's the main thing we're going to learn today right here. If you are multiplying, bases are the same, you add your exponents. So let's try a couple examples. Hold on while I switch whiteboards. So here we go. The first one says if we have x squared times y squared times x to the 5th, of course you can see this gets more complicated really fast, y to the 3rd. The directions for this will say simplify. Now we can only add exponents on like variables, so I'm going to rearrange them. X squared times x to the 5th, y squared times y to the 3rd. Now these bases are the same, and these bases are the same, so we can add our exponents. So this would be x to the 7th, y to the 5th. And it's as simple as that. You add the exponents when you multiply when the bases are the same. Add the exponents when you multiply when the bases are the same. Let's try another one. This one is x squared, y to the 3rd, m to the 5th, x to the 3rd, y squared. Now you can rearrange them in the beginning, maybe that would be helpful to do. Let's put all the like bases together. So we have x squared and x to the 3rd. I'm just going to put them together. And then we have y squared times y to the 3rd. I'll put them together. And then we have this lone m to the 5th. Now when the bases are the same and you're multiplying, you add exponents. Bases are the same, right here and here, we add our exponents. And there's no other m, so we just bring the m to the 5th down. And that's about all there is to it. These are pretty fun, aren't they? Here's another rule. This one says if we have x to the 1 power, it's just equal to x. Like, duh. That's pretty simple. Okay, let's try another one. So, here we go. X, y squared, x to the 3rd. Now here's where this little rule comes in. We're going to have x to the 1st. If it doesn't have anything on it, put a little 1 up there. X to the 3rd, y times y squared. Bases are the same. In your multiplying, you add exponents. Bases are the same on the y's. You have to put a little 1 here. You add exponents. And that's all there is. You guys should like this lesson. This one's pretty fun. Let's try a few more examples. There's 2 parts to this lesson though. Here we go. This one, you have m to the 3rd, p, m, x, m squared, x cubed, p to the 5th. Now you can stop the video right now and try it yourself and then turn it on and see if you got it right. So if you want to do that, stop the video and turn it back on. Okay, I hope some of you tried this anyway. You can do it in your head. You don't have to rearrange them. So let's just start with the m's. We have m to the 3rd, m to the 1 power, and m to the 2nd power. So you can kind of do like this. Bases are the same. We're multiplying. Even though there's not a little dot in between here, when variables are put right beside each other, they're multiplied. So we're going to multiply our m's. That means we add our exponents. So it's like 3 m's. We could put them out like this. M times m times m, and then m times m. But that's just too much writing. So what we're really doing is adding the exponents. So it's going to be m to the 5th. Let's cross those out because I will easily forget we did that. Oops, and we forgot one. See what happens? That was helpful. So we're going to change this into a 6. Let's do that. I can make that look a little bit better, I think. If I just cross that out, there we go. Let's try that again. Okay. I have a neighbor's dog that's barking like crazy. I don't know if you can hear it or not. So m to the 6th, let's get all those m's crossed out, and then let's go to our p's. So we have p, and you put a little 1 up there. So 1 and 5 would be 6. So it would be p to the 6th. And then we have our x's. Put a little 1 up there. If there's no exponents, it's a 1. So we're going to get x to the 1st, x to the 3rd, and so we're going to get x to the 4th. So hopefully if you turn the video off, this is what you got. Okay, that's all there is for multiplying with like bases. Remember, multiply like bases, you add exponents. Now we're going to add like terms just to make things a little more complicated. Let's go to a new board to do that. Okay, so we're going to add like terms. Like terms have the same bases and the same exponents. So I'll show you a couple like terms. So these 3x and 2x are like terms. They have the same variables with the same exponents. These numbers in front of the variables are called the coefficients. I'm not going to write that out, but the coefficients are the numbers in front of the variables. Let's talk about a couple more like terms. What if I had 5x squared yp and 7x squared yp? These are also like terms. I should put an S on this one. Because they have the same variables in x, y, and p with the same exponents on them. These numbers are the coefficients. These are the things that we're going to add and subtract. So let's try a couple problems. What we're going to do is we're going to add like terms. So it'll look like this. X squared, we did this a little bit in class. y p to the fifth plus 2, I'm trying not to make this video awfully long, so I'm talking fast. It's y squared p to the fifth plus 3 p to the fifth x squared y minus 7 x squared x p to the fifth. Okay, first thing I want to do is start looking for like terms. If there's no coefficient in front of it, you can put a 1 in here, like this. This would be 1. So let's see if we have any more x squared y p's to the fifth. So let's look at the second term. That one does not have an x squared, so it's not the same as the first one. Let's go down to the next one. This one has an x squared. It has a p to the fifth, and a y. So these two terms are indeed like terms, so I'm going to underline them. Underline it. Let's check the next one. This should be a y squared right here. Right here, I copied that wrong. Y squared. Okay, let's look at this one. Is it the same as the first one? Does it have an x squared? Well, look, no, it doesn't have an x squared, so it's not like the first term. So let's see if it's like the second term. This one has a y squared. This one has a y squared. This one has an x. This one has an x. This has a p to the fifth. This one has a p to the fifth. So these two terms are like terms. Now, if they're alike, what we do is we add the coefficients. So let's add the straight line coefficients. So we have a 1 and a 3. So before x squared y p to the fifth. And as you can see, the order doesn't matter in multiplication. Remember, 2 times 3 is the same as 3 times 2 in multiplication, so it doesn't matter that the order is different. And then we have a 2 minus a 7, which would be a negative 5 xy squared p to the fifth. And we're going to do one more example, and then we'll be done with the video. You guys can try this one yourself. This is example 6. This is quite long, so you probably want to stop the video just to copy it down. Add like terms. It's 2m to the third x y squared p plus 3p x y squared m to the third minus 10 y squared m to the third p plus y x squared m to the third p. Hopefully I copied that right. Let me just go back and check it. So you have 2m to the third x y squared p, 3p x y to the square m cubed minus 10 y squared m cubed p plus y x squared m cubed p. So you can turn the video off and see if you can do this by yourself. Okay, I hope you turned the video off, and let's see what you got. Okay, this term down here at the end, I would put a 1 in front of it just so that you know what you're adding. Let's start with the first one. It has an m to the third x y squared p. Let's see if we can go find another one of those. This one has an m to the third x y squared p. So these guys are like terms. Let's go to the next one. This one has a y squared. You'll notice, oops, I forgot the x. You probably couldn't do this one on your own, even if you tried. You'll get a different answer. I even tried reading it again. So this one has an x y squared m to the third p. So this is the same. So if you did this on your own, you probably didn't underline this one, so it's okay. This one would probably be by itself. And then when we get down to this final like term, this one has an x squared, and none of these guys have an x squared, so this one is by himself. He does not have any friends. So now we're going to add the numbers in front. So we have a 2 plus 3 is 5. So I'm adding the coefficients. I'm adding 2 plus 3 minus 10 would be a negative 5 m to the third x y squared p plus You don't put the 1 typically unless you're wanting to put it there so you know how to add it. So we just write this yx squared m cubed p. Sorry for frustrating you for leaving that out. If you did the problem, you would just have these two added together and then you would have these two not added together. So that is how you add like terms. So we'll talk about this in class tomorrow if you didn't get it. So that is all for lesson 21.